Yes, Gagandeep. Okay. Good evening, everyone. We'll start our session. Let others join in between. Okay. So a few more are joining. Okay. I'll be sharing my screen. Okay, Gagan, you can go through the previous tutorial, previous session, because this session will be continuation of the previous one. You can stay first. If you can understand, you can continue. It's up to you, or you can stay, or you can watch the first one, and then you can come back to this session. If you are not comfortable, then you can go through the previous session. Yes. Okay. Hope the screen is visible to you all. I request those who are joining to join the session at least 5 minutes before, because once I switch the screen, then I cannot allow, even I'll not come to know whether somebody is waiting or not. So that will be the issue. Okay. Okay. So Gagan has a question. Could you please tell us what you thought last session? Okay, Gagan, in the last session, we talked about the diodes, the basic construction of the diodes. I hope you know that. So if you know, then we can continue with this session. So I'll be switching the screen now. So before starting with the technical session, so let's talk about a little bit of rules and regulations here. So there are three things we will be talking about today. That is the RST, means whenever we communicate in the ham radio or the ham station between the two stations, then the stations inform each other about their signal quality and the signal strength and how it is readable and what was the tone. So there are three terms that is holds good, that is called as RST signal. So whenever the two stations communicate, they will exchange this RST report. So RST, R stands for readability, S stands for signal strength, T stands for tone. And understand, this tone is applicable only for CW transmission. CW means whenever we are transmitting the Morse code, only in that time this tone comes into picture. Otherwise, whenever we are transmitting the voice, it is only the two information we will provide, that is readability and signal strength. So for example, I'm communicating with some station. So when I'm communicating, the first thing which I'll inform them when I hear the other station is that so and so station, you're coming here with this report. So I'll give them report. If it is perfectly readable, then I'll say it is 5. If the signal strength is excellent, then I'll give the report as 5.9. So every time I'll tell your signal strength is 5.9. If I am transmitting it through Morse code, if everything is perfect, the tone is perfect, then I'll give the report as 9. So you have to know this RST, and in that RST 1 to 5, how we have segregated this. 1 we will give if the signal is not at all readable or the information is not at all readable. 2 we will give when it is barely readable. 3 we will give when it is readable with considerable difficulty, and 4 is readable with practical no difficulty, and 5 is perfectly readable. So 1 to 5, it comes like this. So in the examination it will come. So the station receives the signal with barely readable, very weak signal, and filtered rectified. What is the RST report? So it will come as like an option. So you should know what it should be. Now barely readable means 2 and weak signal means 3 and rough note or some trace on the filter means it is 4. So now the RST signal report becomes 2, 3 and 4. So likewise, the signal strength, it is given the rating as 1 to 9. So 1 indicates the faint signal, 2 indicates a very weak signal, 3 indicates a weak signal, then 4 is fair signal, 5 is fairly good, next is good signal, moderate, then strong signal, and extremely strong signal. Next comes the tone. Tone is also rated from 1 to 9. 1 is that is 60 cycles AC. Don't worry about these cycles and all. Because when you learn about this CW transmission, that time it will come at what rate the tones are transmitted. So that there it comes the cycles and all. So 2 is very rough, 3 means rough AC tone, then 4 is rough note, some trace of filtering, then filtered tone, near pure tone, then near perfect tone, perfect tone. So this comes, these questions will come in the rules and regulation paper. So you have to go through this. So please go through this, read and understand RST report. R stands for readability, S stands for signal strength, T stands for the tone. And whenever we are transmitting the voice over the radio, then only the readability and signal strength is applicable. And when we are transmitting the CW signal, then all three will come into picture. Then we will call it as RST report. Okay, so that's about the rules and regulations. So we'll switch back to our technical thing. So in the last session, we are talking about the formation of the P-type or N-type material, and then we combine these two P-type and N-type material, and that will give us in a form of diode. So yesterday we talked about a diode. So what is this diode and why do we need this diode? Let us see what is the function of the diode. So I written a simple circuit. This is an voltage source here, which some say 10 volts. And this is a switch. And this is some bulb. Okay. So when switch is open, what happens? The bulb is off. When we close the switch, the bulb will turn on because the current will flow. Simple concept, isn't it? Now, if I want to control, now how do we controlling the flow of current? Now current is flowing in this direction, that is from positive to negative. It means it is flowing from here, goes to bulb, then it comes back to the battery. Current flows like this. How we are controlling the flow of current? With the help of the switch. Either we'll make it on or we'll make it off by pressing the switch. How do we control the similar operation in the electronic circuit? For that, we need some kind of device which controls this flow of current, and that is achieved by a device called as diode, which we have studied in the last session. So I'll put one simple bulb here. It might be a DC, like this, just for understanding. This is the volts, so I'm applying the 10 volts here. This is some resistance. So now this diode acts like a switch. Okay, we have not completed this diode concept, I think. Before going to the circuit, now let me tell you a few more things about this diode. Now this is the P-type semiconductor material, this side, and this side we have N-type semiconductor material. When we combine, we'll get PN junction diode. And to this PN junction diode, on the both sides, we will connect a metal leads, means like a what do you say, a metal contact points. And the metal contact point on the P side, we call it as anode, and on the N side, we call it as cathode. So we have the two terminals here, anode and cathode. Like if you see the resistor here, okay, resistor is not here. Thought image was deleted. Okay, anyway, it has the two terminals, that is anode and cathode. And symbolically, it is written like this. This is symbolic representation of the diode. A triangle and a bar at the front. So this indicates the diode. And this side is anode and the other end is cathode. If you are confused, let me rewrite this circuit with the help of construction itself. Now this is P side, this is N side. I am just rewriting the circuit. Okay, somebody is waiting to join. Okay. Okay, so this is the anode and this is cathode and this is a resistor. So now it acts like a simple switch. Whenever we connect like this, whenever his anode is connected to the positive terminal of the battery and cathode is connected through this all the way from here to this point to the negative terminal here, then the diode acts like a closed switch. Now the diode is on for the 10 nodes. Now the light is on, so it is glowing. If we connect the diode in a reverse fashion, to the same circuit, then what happens? The light is off. Why? Because whenever we connect in the reverse fashion, it means whenever we connect the cathode to the positive and anode to the negative terminal here, then the diode is off. It will not allow the current to flow in the reverse direction. Okay, so that is why the diode is called as an active component or active device, or component active device. So hope you understood. I don't want to go in much detail. There is something called, okay, I think this will also come in your examination. So let me tell you. So whenever we connect in this fashion, anode is connected to positive and cathode is connected to negative. So it means the diode is in a forward bias condition. Forward bias condition. If we connect in this way, now the diode in a reverse bias condition. So it means the diode will be in off state whenever it is in a reverse bias condition. Means when we apply the reverse voltage, the diode will be off and it will not allow any current to flow because it is open circuit. It is just like this, like an open switch, and the bulb will be in the off state. So hope you understood. Is this clear? Okay. Steven sir, if you message here in the chat box, I'll not come to know. You can text me on WhatsApp if somebody is waiting, because I cannot see even the chat box in Google Meet. There is a drawback of this Google Meet. I can't help it.
Oh, okay, sir. Okay.
Yes, or you can unmute the mic and you can tell also. Yes. Okay. Okay. I just made it very cut short. so that I'll not make it too complicated for you, because in reverse bias condition, the width of the depletion region increases. There are so much things which goes on, and that is all not required for your examination. So I just understand diode is something like switch, and when the diode will be on and when the diode will be off, that is very important for you to understand. So diode will be in an on state whenever it is forward biased. So what do you mean by forward bias? So forward bias means whenever we connect the anode terminal of the diode to the battery and cathode terminal to the negative of the battery, then the diode will be in the on state and it will allow the current to flow in the circuit. Reverse bias means if we reverse the diode connection, it means whenever the cathode is connected to positive terminal of the battery and anode is connected to negative terminal of the battery, then we say the diode is reverse biased and it will not allow any current to flow. So one of the basic electronic component, one of the basic electronic device is the diode, which you can see in most of the electronic circuits. Next, we will talk about transistors. Now, the problem with this diode is, let me give you one example. In your home, you have a light here, maybe a light on the ceiling, a tube light, and you have a switch here, something like this. So what will you do? You will press the switch, the current will flow, the fluorescent light or the LED light will turn on. Now, can you control how bright the light should be? Is it possible? Not possible, because you're just closing the switch and whatever the current is there, the entire current is flowing to that whatever the light it is there. So same thing is happening with the diode also. Diode can only make the allow either to flow or not to flow. It cannot control how much current to flow. Hope you understood my point. So diode can only able to either it will allow the current to flow or it will not allow current, or it will not allow any current to flow, but it cannot control how much current to flow. Okay, so that is why to control the flow of current, so we come up with one more device that is called as one more component called as a transistor. So we can consider the transistor as connecting two diodes back to back. Let me write like this. Let me write it neatly. So let us write the one diode like this, and another diode which is opposite to this one, the first one, like this, and I'll take one more connection from the center point. Now if you write in terms of the construction point of view, there is one PN junction diode, this one, I'm writing this one here. So there is a P terminal and there is a P and N region, and now I'm writing this second diode. This is N and this is P. Now we have the three connections here, and now this N and N is connected, and we take this one more terminal from this point. Now this kind of combination, it is not exactly true. We cannot make two diodes connected back to back actually work as a transistor. There's just an analogy, that's it. Okay, so if you see this, now I'll write the transistor construction diagram so that you can compare this. Okay. This is the actual transistor construction diagram. This is P region, like you can see from here, the P region, and this is also a P region here. And now if we combine, because both are N and N, if we combine these two, it will result in one single region, that is N region. So now we have three regions here. One is P and P. So this region is called as emitter, the middle one is called as base, and the last one we call it as the collector. So this transistor is called as a PNP transistor. We will write it as PNP in short, like this, PNP transistor. Now this will also come in your examination. There might be multiple questions can come from this. So transistor has three regions. This is first region, second region, third region. And it has two junctions. You see, one junction is here and another junction is here. Because you know, whenever we connect P with N, there is a junction is formed. And once again, when we connect N to P, there is one more junction is formed, that is this side. So let me write this as junction 1 and this is junction 2. Now, what is the intention of this transistor? What is the purpose of this transistor? The purpose of this transistor is to allow the current to flow from emitter to collector. But while flowing this, how much current should flow from emitter to collector is controlled by base. Now, that is the function of the base to control the flow of current from emitter to collector. So there are three currents that exist here. We call it as IE, IB, and IC. Sorry, my mistake. This is IC and this is IB. The current which is entering the emitter, we call it as IE, emitter current. This is called as emitter. This is called as collector. And this is called as the base. Because it is collecting all the charges, that is why it is called as collector. And this is the base which is in the center. And this is emitting all the charges, so it is called as emitter. It's some kind of name you can just to remember. Now, there is one more thing which we need to understand here is Kirchhoff's current law. Kirchhoff's current law says that at any junction, if some current is entering, then the amount of exit should also be same. Okay, the sum of these two, for example, if I call this as I1, this is I2 and I3, then I can write I1 is equal to I2 plus I3. Means the sum of incoming current should be equal to sum of outgoing current. Now there is one incoming current and there are two outgoing current. So what happens is that the current is get split here. So we can write I2 plus I3 is equal to I1. It is very simple concept. Or we can also write like this. This is also true. We can write like this also. If the current is coming towards this junction, that is I2 and I3, and the exit current is I1, still it is same. We can write I1 is equal to I2 plus I3. Fine. So the same concept will apply here also. If you look into here, the current which is entering is IE and the current which is exiting is IC and IB. Therefore, we can write the equation as IE is equal to IB plus IC. All right. So there are many applications of the transistor. So one, the transistor is used in amplifiers. Most widely used. This is called as the BJT transistor. This is called as BJT transistor. It means BJT stands for bipolar junction transistor. Why it is called as bipolar junction transistor, that we will see soon. There are other types of transistors also most widely used, that is MOSFETs, which is not there in your syllabus, I think. MOSFET stands for metal oxide field effect, metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor. Compared to BJT, MOSFETs are most widely used in any electronic circuits or integrated circuits because the performance comparatively it is better than BJT. Now, we were talking about the applications. So one of the application of the transistor is in the amplifiers. Next is oscillators. Third is we can use the transistor as a switch also. Now in previous case, what happens? Okay, somebody is waiting to join. Okay. What I was discussing? Yes, the applications of transistors. So transistor can be used as an amplifier. Transistors are used in oscillators. Transistors are used as switches. You might be thinking that why, when we have the diode, why we are using the transistor as a switch? It's a very nice question if you think of. Now, problem with the diode is that we can, once we make the connection in the circuit, we will not going to change off and off. Now, if you want to make it off, we cannot reverse the diode. It is a fixed, means if the current should flow like this, it will flow. For some reason, if some current is coming from here, for example, if there is a one more voltage source here and through resistance, if it is coming, if I want to avoid the current to go backward, at that time I can use the diode. Intention is to avoid the flow of current in this direction. That is the intention of diode. But we are not actually making any device, making anything on and off in the circuit. To make that happen, we will use the transistor. So, like the PN junction diode, a transistor also need to apply with the DC voltage. Now this is the emitter and this is the base, and this is a P type and this is N type. Now forget about the third region here, that is the collector. This is P and P, this is collector. Forget about for time being. Now just consider this P and N. Now when you look into this P and N, it just looks like a normal diode that we have seen before. This is just like a PN junction. Now the PN junction, what is happening here is that we have connected this positive terminal to this P and negative terminal to the base, so that will make it forward bias. I'll write in short, that will make it forward bias. Now what happens? All the majority carriers, that is holes, will move from P to N. Fantastic, fine. Now the ultimate goal is not to make the current only to reach to the base. Ultimately it has to reach to the collector. To make it reach to the collector, we have to reverse bias this collector base junction. When we make it reverse bias, okay, I think we have not discussed about the reverse bias condition of the diode. Then you may not able to understand this. I talked about the forward bias. Yes, I have to bring in the reverse bias concept. So let us pause at this here about the transistor. Let us come back to the diode because we have not discussed the concept of reverse bias. This is P and N. Now what I did, this is anode, this is cathode. Now I've connected the voltage in a reverse order. Means cathode should be connected with negative, but I connected with positive, and anode supposed to be connected with positive, but I connected with negative. So this will set up a reverse bias condition. So what happens in the reverse bias condition is that the width of the depletion at this junction, this width will increase to a very large extent. It will not allow any of these charges to cross because the gap is too much which is created at the junction. So it means there is no flow of current, but there is a very small current which will flow. Now if you see here, the majority carriers are holes. Here the majority carriers on the n side is electrons, but there are minority carriers, the small amount of opposite charge, that is the electrons that exist in p and holes exist in n. Now what happens with this potential? This positive get repelled and this negative get repelled, and those will start moving like this, and this is called as the reverse bias current. Reverse bias current, it will be very small, which will be in terms of say microamperes. Don't worry, I will not go in much of the detail. Just understand that in reverse bias condition, a very small current will flow. That is not due to majority carriers, that is due to minority carriers. So that is flowing. Now if you come back to this transistor here, now these majority carriers, when it comes to the base n, if you see here, this is positive and negative, this will become as minority carriers, and then due to this minority carriers, the current will flow from n base to collector. So thereby the current is flowing from emitter to collector. If anybody has not understood, you can just ask your question. Should I repeat this, or are we good to go? Okay, no response. Okay, so assume that you have understood. So basically, so we have to forward bias this emitter base junction, and we have to reverse bias this collector base junction. This much you understand. For the transistor to work as an amplifier, the emitter base junction should be forward biased and collector base junction should be reverse biased, because again this will come in the examination. For transistor to work as an amplifier, what should be the emitter base junction and what should be the collector base junction? Forward bias, reverse bias, forward bias. So options will come like this. Okay, so you should know what option you will choose there. Then next, we can use the transistor as a switch. Well, let me tell you quickly. For the transistor to work as an amplifier, it should be in an active region. There's something called active region, and there are other region called saturation region and cutoff region. This is used in, this configuration is used when it is used as an amplifier, and these two we will use when it is used as a switch. I'll just write one simple switch circuit. Okay, before writing this, whatever we have seen here, it is PNP transistor. Likewise, we can have the another type of transistor that is called as NPN transistor. Let us write first the NPN transistor diagram. This one. So this is N region, this is P region, this is N region. So it means we are going to sandwich P in between two N regions. So this will act as emitter, this is base, this is collector. So this is an emitter terminal, this is a base terminal, and this is a collector terminal. So symbolically, the transistors are represented like this, the BJT transistors. And to identify this, whether it is PNP or NPN, we put an arrow mark. So if the arrow mark is outward, it means it is NPN transistor. Whereas in this case, for PNP transistor, the symbolic representation of the transistor, it is something like this, and it is inward. So inward indicates that it is a PNP transistor. This is PNP. And how do we identify the terminals? This is emitter, base, and this is collector. So likewise here also, this is NPN, and this is emitter, base, collector. Okay. Now I told you that we will use a simple transistor as a switch. This is an LED, symbolic representation of an LED. It is connected to ground here. So this is plus VCC. It's okay if you do not understand this. I just written one simple circuit. Now, whenever we give, say here, it is NPN. So whenever we give, say 5 volts, the diode will be off. And whenever we give 0 volts, the diode is on. Just understand this much. We give 5 or 10 volts, the diode is off. Sorry, this LED is off. And whenever we give this 0, this LED will be on. It's a reverse case. So it means what happens is that whenever we apply this 5 volts, the diode is on, then the entire current is grounded. Means the current, the potential will come to 0. So what happens is that this LED will be turned off, and I will make it 0 to the base. So then the transistor will be off, then entire current will be flowing through this LED, and that will make the LED to be on. Okay, so before winding up the session, I'd like to introduce one more application, that is the application of the diode. We have studied about the diode and where all we can use it. A simple application is a rectifier circuit. A rectifier is a very common circuit which you can see in your adapters, computer adapters, mobile adapters, everywhere, because for electronic device we need the DC voltage, and whatever we get from the home supply, that is the AC mains, is the analog voltage. We need to convert this analog voltage to the direct voltage, DC voltage. So to do that, a simple circuit that we can see here is we use a transformer to reduce the voltage, and then we can use either one diode or 2 diodes. So let me use the one diode and make you understand what happens, and I'll go with the 2 diodes. This is, say, diode 1, and here we are applying VI, that is the AC signal. Let me call it as V1, and this is V2. Now at the input, the signal is like this. So during the positive peak, what happens is that this upper terminal will become positive and lower terminal will become negative. That will make the diode forward biased. So then the current will flow through the load. If you measure across the output here, so then we will get like this positive peak. But during negative cycle, what happens? The polarity get reversed. This become positive, this become negative. So that will make the diode off. It means there is no flow of current. There is no current. So for the next half cycle, there is no current. And again, for next half cycle, you will get the current. So this is how we are getting only positive peaks. There are no negative peaks. Okay. So if you want to increase the efficiency, then we will use 2 diodes. One diode like this and another diode like this. So in this case, we have to use a center tap transformer. RL, D1, D2. Now what happens is that this is the AC signal across the input. And now across the load, what is happening is this is positive, negative, this is positive, negative. So initially this will be off because the reverse polarity is there. So only D1 is conducting. During positive cycle, we will get a positive peak. And during negative cycle, what happens is that this will become negative, this is positive, this is negative, this is positive. Then this is on, this is off. So that time we'll get the negative peak, that is D2 is conducting. Likewise, for every half cycle, we are getting the peak. It means we are increase the efficiency. When you compare this with this, for entire one cycle, we are getting only half cycle. And for next one cycle, we are getting only half of the cycle. So here the efficiency is less. Here the efficiency is more because we are getting the output for every half cycle. Now, we know that the DC means with respect to ground, it should be a straight line. But this is not a straight line. This is something called, it is called as a pulsating DC. It's a pulsating DC. So to make it the pure DC, we need to add filters. So we have studied about the capacitor and inductor. What is the use of capacitor and inductor that we can understand here? So we just add one capacitor here. When we add a capacitor here, it will filter out the AC component and it will blocks the DC and will get only the DC component. So the output which we get here when we add the capacitor is something like this, almost to a straight line, something like almost a very straight line. And we can increase this efficiency by adding inductor and capacitor together. So we can have a configuration of a capacitor, inductor, and a capacitor like this. We can connect, and this is our resistor. So when we add like this, then finally we will get this, or we can add the resistor at the other end. And this is inductor L, this is capacitor C1, this is capacitor C2, and this is our diodes where we have two connections of the diode. And this is going to the center tap of the transformer like this. Like this kind of circuit we can make our own rectifier which converts from AC to DC. Okay, so we'll just conclude today's session. So today we talked about the rules, a little bit of rules and regulation, that is RST system. So RST stands for readability, R stands for readability, S stands for signal strength, and T stands for tone. And T is applicable only when we are transmitting the CW signal. It means whenever we are transmitting the Morse code. So this you should know it because this will come in the examination. So what is 4, 6, 5 means, or this will be given. You have to identify what is a suitable numbers for that. So that is the thing. And then we had discussed about the diode, forward bias condition and a reverse bias condition, and connecting two diodes back to back will result in a transistor. We have seen a transistor. So this is called as a BJT transistor, bipolar junction transistor. And here the current is flowing from emitter to collector. And we can write this in terms of the current equation as IE is equal to IB plus IC. And the applications of transistor, we can use it as an amplifier, oscillator, or a switch. And also the transistor, to operate in an amplifier, to operate as an amplifier, it should be in the active region. And to operate as a switch, it will act between the two Otherwise, we will. Okay, sorry for that. Sorry for the interruption. So if you have any queries, you can ask. Otherwise, we'll wind up today's session. I just lost the power at home, running a mobile battery.